Hi, I'm Mark Watson, Product Manager of Cincinnati Software Products. Today's question is, how do I import a custom tool into the Ben Simulation tool library? And they ask on this question, it's asked two ways. One is if I have a DXF, and the second one is what if I've got a legacy tool with no DXF? And we'll get right into it. You recognize this. This is the Cincinnati Ben simulation software. It may be a version that may be a little bit newer than you might have, so the icons may look a little different, but for the most part, it behaves very much the same way. Click on the tool library here, all right, and you recognize this. This would be where your tools are currently libraried. It's your spreadsheet version here, and we have the ability here to import a tool. One of the things we need to do, though, before we import that DXF is we have to decide, are we going to do an upper tool or lower tool? And in this case, we're going to do an upper tool, and I'll click on Import Tool. I'll scroll down to where I've got an example here, and I'll pull in this upper tool right here, this tool DXF. And what we get when we do that, our first look here is really a cleanup screen. Your DXF might not be as clean as this one is, where you might have a title block, you might have borders, you might have other views. But really what we want is the one cross section that is going to represent the tool itself. The other thing is we have to make sure that there aren't any stray marks on that. And this one looks awfully clean, but there actually is a stray mark right here on the center line. It's a little dot. And so what I'm going to do is I'm going to turn that capability off there by choosing that. And now the only thing that remains is the white outline of the tool. When I click next, we come to the next part of the conversion of the DXF. We have to create a center line. And sometimes this is done automatically and seen by the software. Sometimes it's not, and we have to manually move it. So when I click on this, we'll just see what happens. Okay, so it wasn't done automatically, so I can just move it over and click on it, and you can see I didn't get it exactly on the center, so I can adjust it to the left. Oops, I went too far. There, I adjust it to the right. There, that's just where we want it. I'll click Accept. And then I click Next. And now what we have to do is we have to highlight the thrust point where this mounts into the tool clamp. And with this being a punch, it's going to mount into the RAM. And this horizontal surface right here is the surface that's going to mount into the RAM clamp. If we have new standard tools from Wela or a Wela knockoff, you can choose by checking this checkbox, you can get your offset off of that for the head-mounted tools. So those tools will mount up into the RAM clamp, and with them not being shoulder mounted, that difference in height is that 1.457 inches. But in this case, it's a standard American tool. Okay, and we'll move to the next step. Here we can create an offset line. I'm not going to do that, but if you were to make or convert an offset die where you're hitting two bends at one time, or you've got a drawing where the center line of the working part of the tool and the center line of the punch tang are not in alignment, you can create that offset line. And that's a very valuable number for you, because if that type of tool is turned around in the software, what will happen is we can then offset the back gauge for the error and the difference of that center line of the working part of the tool and the mounting part. And then we go to finish. It brings it in. You can see the tool now is brought into the tooling library. Here we can do some editing. I'm going to edit the name here. I might call it Test Upper. Okay, and from the tooling catalog where I got the DXF, this is a 75-degree tool. They say this is a 22 ton per foot tool. The radius is a 0.031. And we're really about done unless this is a precision segmented tool set. And if you've got your order from your tool company, you can click on segmented, and here's where you can add sets. So if you have Wilson American, you can add their X, L, and S, and it puts those numbers in automatically. If you have Wilson Euro, you can do the same thing here. Wela has different links, and we've added their numbers as well. So you can do all of that right here. For example, here I'll just put in a Wilson X set and see all the little segments are put in right here. You save that, and you're ready to go. And in the tool library now, this t-test upper, or whatever I called it, this is now available for your use. But the second part of the question was, what if I want to do something similar to that with a legacy die that I've got on the shelf? Who knows when somebody bought it, but we need to get that legacy tool added. How do I do that? And rather than click on import tool, what we can do is click on the new tool choice. This new tool choice allows us something very interesting here. We can actually dimension cartoons, and based on the dimensions that we put in, then we'll get an outline view that will be very precise, actually. So let's start with that. If I begin to do this, I might call this, let's see, test upper 2, okay? And what I've got is I've got a number of things I can do. I've got a number of punches, radiuses, and goosenecks, right? And flattening dies. But let's just take this one right here. And let's say I've got a 75-degree tool. The height, let's say it's a little taller than this. Let's say it's 6 inches tall. It runs at 30 tons a foot. And now with a legacy die, how are you going to determine that maximum loading of 30 tons a foot or 20 tons a foot or whatever? Well, the way you would do that in our press brake manual, we have that method for all different types of tools. So please refer to your manual on that. We'll put in the length of the tool. Let's say it's a 72-inch long piece of tooling. The radius on the punch, let's say it's 0.062, right? Okay, about a 1/16 of an inch radius. Let's say the tool has a little bit of an offset. It was made on a planer and it's not quite as accurate as we might like. Let's say it's got a 10,000ths difference, 0.01, 10,000ths off. And the clearance is what's going to protect our back gauge fingers from slamming into the back of either the punch or the die, in this case, the punch. We want to know that distance, that C distance, measured from the center line of the tool to the backside. So let's say that is 0.625, okay? And now when we go to our outline view, there's our tool, okay? And all I've got to do is click Save, and test 2 upper is saved, just like that t-test upper was from the DXF. I hope that helps. We'll see you next time. Thanks.